All right, let's talk about a subject that gives a lot of people nightmares, organic chemistry. But today, we're not here to dwell on the struggle. Nope. We're going to dive into a piece of tech that's completely flipping the script on how we learn it.
Does this look familiar? I mean, if you've ever been through OChem, you know the drill, right? You spend hours just memorizing all these reactants, products, those crazy arrow-pushing diagrams, and you're just hoping, praying, it all makes sense before the big test. It's this classic struggle. It's all about memorizing stuff, not actually getting it. And then you get to the lab. You know, traditional labs have some pretty major drawbacks. First off, you're dealing with hazardous chemicals. Then there's the super expensive equipment, and you've got this immense pressure because you basically have one shot to get the experiment right. It's not exactly the best place for real curious learning, is it?
Okay, but what if you could just get rid of all those problems? Well, that's where this incredible solution comes in. Let's talk about the virtual lab. So what are we actually talking about here? Basically, an organic reaction simulator is a piece of software that lets you build and see chemical reactions happen right on your screen. And the most important parts? It all takes place in a totally safe digital world. No risk, no cost, none of the real-world lab headaches. And this really gets to the heart of it all. The whole point is to move away from just memorizing what happens in a reaction and to start truly understanding why it happens. It's a huge difference. So what's it actually like to use one of these things? Picture this, you're the student. You get to choose an experiment from a whole library of options. Then you get to be the scientist. You can tweak the temperature, change the concentration, whatever you want. And then you just watch. You see the bonds forming, the electrons moving, all in real time. And the best part? If you mess up, who cares? You just hit reset and go again and again and again. No problem. You see, this is so much more than just a new gadget for the classroom. It's a totally different way of thinking about learning. We're shifting from just sitting back and listening to actively jumping in and exploring. And when you compare the two, I mean, the difference is just night and day. Think about it. A traditional lab is like following a super strict recipe. You've got real dangers, real waste. But in a virtual lab, it's all about exploration. You get to ask, hey, what if I do this? And you see the answer instantly. You can make mistakes safely and try over and over without wasting a thing. But you know, maybe the coolest thing about this is how it makes the invisible visible. Chemistry is all happening at this tiny molecular level we can never see. You know, on paper, a reaction is just a bunch of letters and arrows. But in the simulator, you can grab a molecule, spin it around in 3D, and literally watch another molecule come in and react with it. Suddenly, all those abstract diagrams, they just click. You finally see what the textbook was trying to tell you. Okay, so this all sounds amazing, right? But here's the real question. Does it actually work? Is there any proof that this stuff actually helps students learn? Well, let's take a look at the evidence. So, a case study was done to figure this out. They had 39 people use a virtual lab to do some pretty complex chemistry stuff, and wow, the results speak for themselves. First up, efficiency. Check this out, almost 95%. 94.87 to be exact, of the people in the study said the simulator helped them learn more efficiently. That's nearly everyone. They were understanding things better and faster. And here's another huge one, safety. Over 92% of them said they felt safer using the simulator, and that is massive. Think about it. When you take away that fear and anxiety, students can just focus on what really matters, learning and discovery. So you can see this is way bigger than just making one tough class a little easier. We're talking about technology that could completely redefine what a science lab even is, and that has huge implications for the future of education. What this really does is it opens up science to so many more people. It makes quality education accessible to everyone. I mean, it's perfect for remote learning. It lets schools that don't have big budgets run sophisticated experiments. It basically levels the playing field so every student gets the same great experience, no matter what school they go to. And when you add all that up, the result is pretty clear. Students using these tools aren't just cramming facts for a test. They're actually more motivated, they're more confident, and they're walking away with a much deeper understanding of science that's actually going to stick. They're learning by doing. So let's leave you with this thought. We've just seen how a really tough subject can be completely transformed by taking it out of the physical lab and putting it into this interactive virtual world. It really makes you think, doesn't it? What other areas of education are just waiting for this kind of revolution?
What's next?
Virtual labs are completely changing science class as we know it. Let's explore how.
So, what's wrong with old-school science labs? Well, they've got some pretty big problems. For starters, they're expensive, can be dangerous, and honestly, not everyone can even get to them.
But what if you could bring the lab right to the student? That's the game-changing idea here.
Enter virtual labs. They're interactive simulations that bring cutting-edge science right to your screen, safely.
We're talking about exploring the newest, most complex ideas with absolutely zero physical limits. Okay, so what can you actually do in one of these labs? Let's take a look. They're built around 4 key themes, basically the absolute heart of modern biochemistry.
To make this feel real, let's jump inside a genetic simulation for DNA sequencing.
A super complex process gets broken down into simple, easy-to-follow, and repeatable steps. And it's not just genetics. You can also run other core experiments, like the amylase test.
So when you put them side by side, the advantages of virtual labs really just pop.
And the number of safety risks from hazardous materials in a virtual lab? Exactly 0. For learners, this is huge. You can visualize tricky concepts and practice experiments over and over.
And who benefits from all this? Well, pretty much everyone involved in science education and research.
But, this is about way more than just swapping out beakers for pixels. It really closes that gap between theory and practice, making science accessible to literally anyone.
So it really makes you wonder, is the future of the science classroom actually on a screen?